Welcome to section 0.7, probability with permutations and combinations. Today's objectives are to find the number of possible outcomes of an experiment and use permutations and combinations with probability. Terminology you need to know is if we have an experiment, it's a situation involving chance or probability. We have a sample space, which is a set of all possible outcomes. So if you roll a six-sided dice, there are 6 possibilities. That's your sample space. You have independent events, outcomes that do not affect each other. So it's things that you do, rolling a die will not affect me flipping a coin. They're independent. Rolling 2 different die, rolling 1 die will not affect the roll of the second die. And then we have dependent events that the outcomes do affect each other. Let's say you had a bag of marbles that had like 15 marbles in them, different colors. Once you pull one marble out, now there's only 14. You have affected the outcome for the next pick. As long as you don't replace it, you'll have a dependent event. Because every time you remove something, there's one less that you could possibly get. Then we have the fundamental counting principle. If A and B are 2 events, if event A has n sub 1 possible outcomes, and event B has n sub 2 possible outcomes, then event A followed by event B has, you multiply their possible outcomes together. This works for 3, 4, 5, 6 events. So like I said with the die and the flipping a coin, rolling a dice, you have a 1 in 6 chance. You have 6 possible outcomes, I should say. And then with a coin, you have 2 possible outcomes. So when you do them together, one after the other, you have 12 possible outcomes. The factorial, if you haven't seen these before, it's denoted with the exclamation point. The factorial of a positive number, n, is the product of all the positive integers less than or equal to whatever n is. So 5 factorial is 5 times 4 times 3 times 2 times 1. A lot of times people drop that times 1 because it doesn't change anything. 10 factorial would be 10 times 9 times 8 all the way through. And then by definition, 0 factorial equals 1. You'll see when we do permutations and combinations why this is the case. But 0 factorial is equal to 1. So permutations. The number of ways n objects can be arranged in a certain order. So they have to be in a specified order. So if we have permutations, we have n objects taken n at a time. So if I have 7 books and I'm going to order 7 books on a shelf, I'm going to take 7 books, order 7 books, so it's 7 permutation at 7, or 7p and 7. This is the same as doing 7 times 6 times 4 times 5 times 4 times 3 times 2 times 1. So npn is 7. It would be n factorial. Let's say you had those 7 books and you only want to order the first 3 of them. Then we have this n objects taken r at a time, npr. For this you take n factorial divided by n minus r in parentheses factorial. This will be like, and I'll show you some examples of this here on the next slide. So here we have, an alarm system requires a 6-digit code using the digits 0 through 9 with no repeats. How many codes are possible? So if you think about this, when you have your selection of your first digit, you have 10 possibilities. 0 through 9, there's 10 numbers. Then the second number, you have used one of the numbers, so now there's only 9 left. Now you've used 2 numbers, now there's only 8 left. All the way down until you've got your first 6 digits that you're going to use. This is the same. I'll write the rest of it out actually. So there's your 4th digit, here's your 5th digit, and here's your 6th digit. That is the same as having 10 permutation 6. I have 10 numbers I can choose from, and I'm going to order 6 of them. There is a way to do this on your calculator. Instead of having to do it by hand, I'm going to show you by hand because you guys need to be able to do it by hand also. So this is 10 factorial over 10 minus 6 factorial. This is 10 factorial over 4 factorial. So we do these, when you look at 10 factorial, if we just have 10 factorial on the top, you'd have 10 times 9 times 8 times 7 times 6 times 5, all the way down to 1. On the bottom, you'd have 4 factorial, it would be 4 times 3 times 2 times 1. Well, what ends up happening is that you'll have that 4 factorial part will repeat in the numerator and the denominator, and they cancel out. So all you have to do is take 10 factorial over 4 factorial. You're going to be left with what we started with right here. 10 times 9 times 8 times 7 times 6 times 5. When we do this, you get 151,200. That's how many possible codes there are if you take 6 digits without repeating. On your calculators, there's ways to do this also. If you take your calculator and go to math, and then go to probability, there is option 2, which has NPR. And if you select NPR and type in 10 for the first box, 6 for the second box, it will give you this. Like I said though, you have to be able to do this by hand also. The next thing it says is, if a code is randomly generated, what is the possibility the first 3 digits are even? As we have to break things down a little more, our even digits are 0, 2, 4, 6, and 8. So we have 5 of them. So we're going to do a random generated code, and we have to have the first 3 digits are even. So we have 5 to choose from, and we want 3 of them, 5P3. We still have a 6-digit code, so we need 3 more digits. Well, we've used 3 of the digits already out of the 10. This is 7 remaining digits that are available, and we're going to choose 3 of them. And if you did the math here, you'd have 5 factorial over 5 minus 3 factorial times 7 factorial over 7 minus 3 factorial, in parentheses, 7 minus 3 part anyway. This would be 5 factorial over 2 factorials times 7 factorial over 4 factorial. We do this, you're going to be left with 5 times 4 times 3 in the numerator of the first one. And the second one, you're going to have 7 times 6 times 5. Or you do this on your calculator, like I said, if you don't, like I said, you have to be able to do this both ways, by hand and using your calculator. I'll allow that for some. This is 12,600. All right, so there's 12,600 combinations when we restrict those first 3 digits to evens. And again, on your calculator, you could do math, probability, 5P3, and then times, choose math, probability, 7P3. We are now looking at combinations. Combinations are the number of ways an object is taken out of time when order is not important. So when we did permutations, the order made a difference. With combinations, we don't care what the order is. So we have the number of combinations of n objects taken r at a time is NCR. Sometimes you'll hear this called n choose r. And it's n factorial over n minus r factorial, like what permutations was. But then we add in the denominator r factorial. The r factorial at the end gets rid of any duplicates you would have. Here's a combination problem. There are 7 seniors, 5 juniors, and 4 sophomores on the PEP squad. Mr. Reinhardt needs to choose 12 students out of the group to sell spirit buttons during lunch. How many ways can 12 students be chosen? And here we don't care about order. We don't care if they're seniors, juniors, or sophomores. We just want to pick 12 of them. So what we have to do is we have to figure out how many total students there are. And in this case, there are 16 students. Well, we're going to pick 12 of them. We want to choose 12 of them, so we're going to do 16. Choose 12. All right, that's our combination. This is 16 factorial over 16 minus 12 factorial, 12 factorial. We do just, I'm going to do this, we will simplify this a little bit first. So we have 6 factorial, we have 4 factorial times 12 factorial. Well, I'm going to do the 16 over 12 factorial. 12 factorial beyond the 12 times 11 times 10 is going to be repeated between the numerator and denominator. So in the numerator, all I have left is 16 times 15 times 14 times 13. In the denominator, we have 4 factorial, which is 4 times 3 times 2 times 1. From here, we simplify what we can. Well, we can take a 4 out of 16. We can take a 3 out of 15, leaving 5. We can divide a 2 out of 14, leaving 7. And we are left with 4 times 5 times 7 times 13. And when we do this, we get 1,820. Again, we can do this on our calculators. Go to Math, Probability, but now I'll choose option 3, which should be your NCR. For part 2 of this, it says, what is the probability 4 seniors, 4 juniors, and 4 sophomores are chosen? We're looking for probability now, so we're going to look at the way we can choose these 4 seniors, 4 juniors, 4 sophomores over the total number of ways we can choose 12 students. So we have a 2-piece thing going on here. First, we need to figure out how many ways we can choose 4 seniors, 4 juniors, 4 sophomores, and divide it by that number we got from part 1, which is the total number of ways we can choose 12 students. So if you have 4 seniors, there are 7 seniors in total, so 7, choose 4, and then we have 4 juniors we want, and there's 5 juniors, so 5, choose 4. Then we have 4 sophomores, and we want to choose 4 of them, so we have 4, choose 4. That is the number of ways we can choose 4 seniors, 4 juniors, 4 sophomores. Our total number of ways we can select 1,820, so we have to divide out because we're looking for probability. And then we do our math. We have 7 factorial over 7 minus 4 factorial, 4 factorial times 5 factorial over 5 minus 4 factorial, 4 factorial times 4 factorial over 4 minus 4 factorial times 4 factorial. This is all divided, we have a compound fraction here, by 1820. So when we simplify these, we have 7 factorial over 4 factorial. That becomes 7 times 6 times 5. We have that 7 minus 4 factorial, which is 3 factorial left, which is 3 times 2 times 1. And we have 5 factorial over 4 factorial, leaves just the 5. We have 5 minus 4, which is 1 factorial, which is just 1. We have 4 factorial, which cancels to 1 in the numerator. And we have 4 minus 4, which is 0 factorial. And if you recall from earlier in the slides, I said that 0 factorial by definition is 1. And this is why it is 1, because this happens with combinations or permutations. All divided by 1820. We then simplify our numerator. We have 3 times 2, which is canceled out to 6. So we have 7 times 5 times 5 all over 1. We just have 7 times 5 times 5, which is 175 divided by 1820. And then we start simplifying this down, right? They're both divisible by 5. 5 goes in 35 times. 5 goes in 364 times. These are both divisible by 7, which leaves 5. 36 divided by 7 is 5, leaves 14, 5/50 seconds. That's my probability. So our probability is 5 over 52 for picking 4 seniors, 4 juniors, and 4 sophomores to be our 12 students. This is what you have to do. Like I said, some of this you have to do by hand. Some of these you'll be able to use your calculator, which I'll show you on the assignment list. All right, that is all for section 0.7, permutations and combinations with probability. Thank you for watching and have a nice day.